Today, we turn to a tool that serves as the foundation for the 7 quality control tools and is often the very first step in any quality investigation, the check sheet. Simple, yet powerful, it is where effective data collection truly begins. A check sheet is a structured form used to collect and record data in real time at the location where the data is actually generated. It makes data collection consistent, organized, and easy to analyze. Rather than scribbling observations on scattered notes, you give every operator the same form, designed around the specific question you are trying to answer. The result is reliable data that everyone records in exactly the same way. There are several common types, and the right one depends on what you need to learn. The defect check sheet is the most familiar. You list the categories of defects you expect, and operators add a tally mark each time one occurs. The defect location check sheet replaces counting with a drawing of the product, where each defect is marked on the exact spot it appears, which quickly reveals where problems cluster. And the confirmation or checklist check sheet verifies that each step of a process or inspection has been completed, which is common in maintenance, machine setup, and standard work. Let us make this concrete with a completed defect check sheet recorded on a plastic injection molding line over 1 week. Start at the top. The header identifies who recorded the data, where it was collected, and the dates it covers. These 3 pieces of information are essential: who, when, and where. They make the data traceable so that when a pattern appears, you know exactly which line and which week it came from. A check sheet without this context is just a pile of numbers. Below the header, the left column lists the defect types, the categories that were defined before any data was collected: short shot, flash, sink marks, burn marks, and so on down the list. Because every operator works from the same categories, a given defect always lands in the same row. Across the top, the columns break the week into days, from Monday through Friday. This adds a time dimension so you can see not only what went wrong, but when in this specific week. Inside the grid, every tally mark is a single occurrence recorded at the moment it happened by the operator rather than reconstructed from memory at the end of the shift. Now read the totals. The column on the right sums each defect type across the whole week, and one figure stands out immediately. Flash occurred 22 times, far more than any other defect. That single number already tells you where to focus first. The row along the bottom sums each day, and Wednesday stands out as the worst with 20 defects, which is a clue worth investigating on its own. So, a single completed sheet has already done real work. Without any further analysis, it has ranked the defects and flagged the worst day, and those totals drop straight into a Pareto chart, which is the tool we cover next. A few best practices will help keep your check sheets effective. Keep them simple because every extra column adds friction. Pilot the form with a few operators before a full rollout, as a form that is awkward to use is more likely to be completed carelessly. Make sure everyone who uses the form is trained in the same way so that a single tally mark means the same thing to every person on every shift. Finally, review the data collection process regularly to ensure it is running smoothly, and wait until enough data has been collected to support a clear conclusion rather than rushing to finalize results based on insufficient evidence. To summarize, the check sheet is the disciplined first step in data collection. It standardizes how data is recorded and provides a solid foundation for every analysis that follows, helping to reduce errors and improve process. The rest comes down to how well you apply and practice it. And that covers almost everything you need to know about the check sheet. If you found this video helpful, be sure to subscribe so you do not miss more content on quality engineering and continuous improvement. Thanks for watching, and I will see you in the next one.